All right, hello everybody. So I want to kind of quickly review what we did for sine and cosine, and then also look at a few of the other trig functions before we get to the inverse trig functions. Okay, so with our y equals sine x, our domain was all real numbers, say negative infinity to infinity. Our range was negative 1 to 1. Our period was 2 pi. And I got a graph like this, where the important things are that the sine function goes through the origin. Sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0 if we think about our unit circle. And I got you to graph a few of these on Alex, right? Okay, at least a few periods. Now, what we want to think about in 6.1 is, does this function have an inverse? And normally, in order for a function to have an inverse, it has to pass something called the horizontal line test. Now, I would assume that you've seen this before. You have a vertical line test to determine whether something's a function. And that means for every x value, there's one y value, right? If it passes vertical line test. Horizontal line test means that for a particular y value, I can only have one x value. And notice here, this graph doesn't satisfy the horizontal line test because for, say, the y value of 1, I'm not sure which x value would be my output. So at first glance, we might say, well, this function doesn't pass a horizontal line test. It doesn't have an inverse. But what we actually do, and I will talk about in a little bit more depth later, but they chop this graph up. They kind of get rid of most of it, and they look at that kind of restricted sine function. And from there, they get the sine inverse function, okay? So they actually chop off everything, but this little piece right here, so we go from, say, negative pi over 2 to, say, pi over 2. Actually, sorry, I went a little bit too far. They actually chop off everything but that. And you'll see with that little piece right there, we can actually recover everything. We can actually find, if I thought about just this part that I've highlighted here, if I thought about a horizontal line here, then it would pass the horizontal line test. So they kind of chop off part of the graph, okay, so to speak. And we're going to do that with sine, cosine, and tangent. All right, let's look at cosine. All right, so here's cosine. And for cosine, you may remember that actually all of these three things are the same. So domain's negative infinity to infinity, range is negative 1 to 1, period's 2 pi. Cosine looks very similar to sine as we've talked about. They actually chop off cosine on this little bit here. So in order for this guy to have an inverse, when I'm talking about the inverse, they actually kind of throw away all parts of the graph except this little guy right here, from 0 to pi. And then it would pass a horizontal line test. Okay. What about tangent? I didn't actually show you the graph. I was going to, or maybe I did. Maybe I didn't. It's a crazy one. Okay. And I'll try to explain where this graph comes from a little bit. Remember, we have some problems in the beginning when we tried to find like tangent of 90 degrees. Remember how we had that problem? Just think about our unit circle here. And tangent's y over x. So if I'm trying to do like 1 divided by 0, okay, so that's at 90 degrees or pi over 2 radians, right? Or I'm trying to do, say, I wrote 0, okay. Sorry, 0, 1, and 0, negative 1 here. So if I try to do 1 divided by 0, y divided by x, I can't do that. And same thing down here with 3 pi over 2. That's also a bad value. So tangent actually has a domain where it's all real numbers, but x cannot equal, and I think I may have mentioned this, I'm not sure if I did or not, but x cannot equal n pi over 2, where n is an odd integer. So for instance, give me an odd integer like 3 or 5. X can't be 3 pi over 2. X can't be 1 pi over 2, pi over 2. X can't be negative pi over 2. Any of those values give me vertical asymptotes. Everything else is fine. Just to show you an example, if I do like x equals pi divided by 2, I get a vertical asymptote. Okay, so no good. So that's our domain, our range. What would you say the range was for this graph? It's all real numbers. In a way, negative infinity to infinity. Which I could have wrote that up here too. But in a way, right, we already knew that. Because remember when I said tangent theta can be any number, right? So tangent theta could be 2. Tangent theta could be 50, right? Tangent can be anything. I was already saying the range is all real numbers here. Well, this is what our graph for tangent looks like. Okay. And the other thing I do want to mention is that the period is actually not 2 pi. The period for tangent is pi. I would actually try to remember that because that's a fact that comes in handy. And that's if I go from, say, like, the reason for that is because you can see this pattern. But when I look at these asymptotes, I go from negative pi over 2 to pi over 2. This distance, pi over 2 plus pi over 2, that's just pi, right? So the period is pi. Every pi units, I'm going to be getting a graph that kind of repeats over. So period is just pi instead of 2 pi. So I would try to also kind of remember that about the tangent, what its domain, range, and period are. Other than that, and just the basic shape of the graph. One way to remember the graph, if you remember 3 points, you've got it. Like tangent of 0 is 0. And then tangent of pi over 4 or 45 degrees, that was 1. And tangent of negative pi over 4 was negative 1. So a lot of the time, if you just kind of think about graphing these 3 points, pi over 4, 1, 0, 0, and negative pi over 4, 4, then you can already get kind of a good graph of what the tangent is going to look like. And then that pattern just repeats. Okay. Well, what do the other graphs look like? I'm just going to show you what they look like. Real quick. And I wouldn't spend a ton of time thinking about these graphs, what they look like. Okay. But you should at least be aware kind of what they look like, I guess. But they're not a key part of this. Okay. So cosecant x. Now, how on earth does that graph happen? So that looks a little mysterious. I would think of it as cosecant is the reciprocal of sine. So I'm also going to graph in sine. Okay? Now, hopefully you can see that value. So what's happening here? Well, the cosecant is just a reciprocal. So here, this y value is 1. If I do the reciprocal of 1, I get 1. Here, the y value is about 1/2. So if I do the reciprocal of that, I get 2, right? Here, y value is negative 1/2. So reciprocal, that's negative 2. Really, this is just a reciprocal. Whatever y value I have for the sine, if I do the reciprocal of that number, I get the cosecant. Then I can see I got these vertical asymptotes here. Because when the sine's 0, 1 divided by 0 is a big problem. So I get this vertical asymptote. And so what I end up with is getting this shape here that I had for the cosecant Again, not super important, but the cosecant looks something like this. Secant's going to look similar, but you're going to have problems at slightly different place. And then the cotangent looks similar to the tangent, but it's shifted a little bit, and then the graph's also kind of going a different direction. So those aren't huge. If we had more time, I would probably talk more in depth about these domain and range of all of these, but just be aware that those graphs exist. Okay. Now, kind of back to the inverse trig functions. That was kind of what we really wanted to look at here. Now I'm going to turn this light back on. So your sine, cosine, tangent, know your domain, range, period that I wrote down there. The other stuff, don't worry too much about it. And then the other thing that you really need to know is this. So inverse trig functions. Okay. So we have something like y equals sine inverse of x, right? Remember, I can also use that arc sine instead of sine inverse. So I can also write it like this as well. Whether I write it like this or this, it means exactly the same thing. Now, what's our domain? What's our range? Okay, so I think I mentioned in the video, and I'll draw up kind of the situation that we had, but I believe that I said that our sine, we were going to restrict it to something like this, and I believe I kind of cut off all of the sine except for this little piece right here. And I said all the other parts of the sine, we're getting rid of this. So this was like the restricted sine. Restricted y equals sine x. And I restricted it in such a way that the domain now, for that restricted version, was negative pi over 2 to pi over 2. And the range was like negative 1 to 1. Okay. So if I think about the domain here and the range here for the inverse, how do they compare? They're flipped, right? The function and its inverse have domain and range that are flipped. So with this restricted sign, our domain was negative pi over 2 to pi over 2. That becomes the range for my inverse sign. And since my range was negative 1 to 1 for my sine, my domain becomes negative 1 to 1. If you remember nothing else, which from this part, you don't really need to know that per se. It just helps trying to explain it a little bit. You really need to know the domain and range for this arc sine because if I calculate sine inverse, I have to know what output I can have. Okay, this means that I'm not allowed every possible output. Right? Same thing, I'm not allowed every input. So I might put a number in there where I can't take the sine inverse to 2, for instance, because that's not the domain. So knowing the domain and range for this sine inverse, that's really important. Okay, so make sure that we know this. I'd also point out that domain is x values here and the range is y values for our inverse here. Okay, so I'm going to write down the other ones. And not talking about the restricted, just I'm going to write down what the domain and range is for these. So domain and range. So for cosine inverse, our domain is actually the negative 1 to 1. And our range is actually 0 to pi. And the other one, really important one, is going to be this tangent inverse of x. And there your domain. Well, that one's actually ironically kind of the easy one to get. So let me just kind of mention for that one, you actually just kind of restrict it to this on your original graph. So remember how I said for y equals tangent x, the range was all real numbers. So your domain is actually all real numbers for your inverse. Maybe I'll just write that as negative infinity to infinity there. And your range is going to be from negative pi over 2 to pi over 2. Non-inclusive. Okay, so what I have on the board is what you need to know. Okay, I don't want you to get scared. All right, this is what you need to know for this part. And then what we're going to do now is go through and compute some values. Okay, but I would like you to take some time and kind of know what the domain and range is for these inverse functions. All right. All right, I think that will be good. And then I'm actually going to do some problems where I compute this in the next video.